Alrighty, so we're going to be looking at lesson 9 for computer science discoveries. I'm going to go through bubbles 3, 4, 5, and 6 in this little tutorial video. The counter pattern can be kind of confusing and a little bit difficult, so I figure I'd give you a little bit of a jump start on the first couple of bubbles here. To start out though, I think it's really important to read through this third diamond bubble. I know that everyone always reads through all of those diamond bubbles, but let's just give this one a little bit of an extra look because this is kind of a scary, weird kind of topic. So let me zoom in so I can read a little bit. Okay, so the counter pattern is for increasing or decreasing number. Oh, never mind. Hold on. Let's just read through it as they say it. So increasing or decreasing numbers is a common and incredibly useful pattern in programming. This counter pattern can be used to make an image fly across the screen, to count down a timer, or to keep track of clicks. Used with the variable x to count up by 1, the counter pattern might look like this. And this right here, this image, is the core of the counter pattern. You're going to start with some variable that has some value associated with it. Maybe starting at 0, or maybe starting at a higher number and then going down or even going up from that higher number. And what you do is you're going to say, all right, x is equal to itself plus 1 or minus 1 or times 2, however you want to do your counting by, right? And what this will do is, let's say that x had a value of 5. When I run into this line, x is now going to be assigned a new value of itself, so 5 plus 1, x would now hold the value 6. And if we're in a loop, like a draw function which just loops forever, it's just going to say, all right, well, x is equal to itself plus 1, so it was starting at 5, it'll go to 6. The next time we go through the loop and it hits this again, it'll be at 6 to start, we'll add one more, it'll be 7. And every single time you run through the loop, it's going to add 1 to this counter variable. And that's kind of like what's going on. I just explained what this says over here. Okay, so now let's take a quick little look. This animation over here, this little GIF, has a bunny, a hippo, and a pig, and they're all moving across the screen in different ways. The pig is moving across from left to right, the bunny is moving from up to down, and then the hippo is moving diagonally from the top left corner to the bottom right corner. So let's take a look at the block code that they gave us here. They started by setting up the 3 different sprites. So they made it a variable, hippo, it started at 30, 30, a rabbit, and a pig, all with their starting coordinates, and they set their animation accordingly, right? Now we get to the draw function. And I don't think in my previous videos I actually got a chance to talk about the draw function too much, so just super, super quick. The way the draw function works is, once you enter the draw function, until, there's a way to exit functions later on that we'll talk about. Basically, once you enter the draw function, you're stuck in it, and it is going to loop forever. So it starts the draw function, it executes each of the lines one by one, and when it gets to the bottom of the draw function, it jumps back up to the top and repeats. And it repeats, and it repeats, going on indefinitely until you decide to end the program. That's the only way we know how to end it right now. So we have the hippo, the rabbit, and the pig all set up. Let's take a look at exactly what's happening over here. So they started by saying, all right, we're setting the background to be white. And then they say the hippo's x-coordinate is equal to its own x-coordinate plus 2. And they also say the hippo's y-coordinate is equal to its own y-coordinate plus 2. Now don't forget that the coordinates start at 0, 0 in the top left corner and go to, I think it was like 400 or 400 in the bottom right corner, right? So the x goes positive to the right and negative or lower to the left. The y is the opposite of what you would normally think. It actually is positive going down, and you subtract to go up. So what's happening is we're changing the hippo's x and y coordinates by plus 2 every time we go through it. So every time I jump through this for loop, the hippo is going to move a little bit to the right and a little bit down, a little bit to the right and a little bit down, a little bit to the right and a little bit down. And since it's happening so fast, it appears like the hippo is moving diagonally because it's moving to the right and down. Same thing with the rabbit, except the rabbit's not changing its x-coordinate at all. It's just changing the y-coordinate, right? It's just every time we go through this loop, it's going plus 2 to the y. Similarly with the pig, it's going plus to the x, which makes it go to the right. And I realize on my screen, I think it's mirrored, so to the right looks like this way maybe for you guys. Finally, we draw the sprites after the coordinates have been changed. And then we reset the background to be white. And if you remember from the other loop video, all that's doing is just saying, hey, I'm not going to get like a stream of hippos across the screen, right? It's going to just draw it and then reset and like cover over the previous sprite, which makes it appear like it's moving instead of being drawn 8 million times. Okay, just another quick thing to note before we do work on the others, because I know I've been talking for a little while, but I just want to note it. You can use the counter pattern for anything. It doesn't just need to be the x or the y coordinates of it. It can be lots of things. This sprite rotation is kind of hard to see because it doesn't fit in. But, sprite.rotation equals sprite.rotation minus some amount, and it'll spin it. Sprite.scale equals sprite.scale plus 0.01. It's going to make it get bigger, right? As you're changing the scale over and over as it loops. And this is kind of cool. I like this animation over here. It starts as I don't know exactly what was going on there, but it started as like a tall thing over here. We're making the width larger every time we run through the loop, and the height smaller every time we run through the loop. So it makes this cool looking animation. So you can do like a lot of cool stuff with this counter pattern when you start playing around with it more. All right, so that's enough of me talking. Let's do a couple sample problems just to like see what's going on. Okay, this pattern is one of the most important ones of all programming, the counter pattern. You can use it to increase the value one. Yeah, I just talked about it a bunch. All right, so do this. Read the program and make a prediction of what the output will be, and then check your prediction. So let's take a look. It just says change it. I don't know why I have that there. Misspelled too. So we start with the counter at 0, and then we have our draw function, and it's going to do the background white so that every time it will, cover over the previous thing. And it says the text size is going to be switched to counter. And then the text is going to be counter at the coordinate 0, 400. So I'm never changing the coordinates. I am changing the text to be counter every time. And I'm changing the text size to be the size of counter every time. And then it's counter equals itself plus 1. So then every time we run through this loop, right, it's going to start at line 3. Great, we're in the function. Cover over with a new white background. Change the text size to the counter. And then we're going to say, all right, the text is going to be counter at those coordinates. And then we're going to, iterate. We're going to increment is what I mean to say. Increment, which just means, add 1 to counter every time. Get to the bottom of the loop. Do it all over again. So what do you think is going to happen here? Take a moment, pause the video, see if you can come up with a good guess. And then we're going to hit play and see what happens. All right, so I'm going to hit play and see what happens. So what happened is the text, all right, let's reset. Oh, I can't pause it. All right, so I'm going to start it and we're going to start looking. So the text starts out really small and it's getting bigger and bigger and bigger. And the number in here is getting bigger and bigger too. And that's because, well, what we did was we're saying the text size is going to get bigger as counter gets bigger. And notice, I'll reset this one more time. It's going up by 1 very quickly, but it is going up by 1. So the text size is getting bigger by 1 every time. The text itself is using the value counter to be what is there. So it's actually displaying whatever counter is holding on to at the moment. And then the way that it keeps going up is this counter pattern. Every time I go through this loop from line 3 going down through line 8, counter gets increased by 1 at the end of every time. We change the text size so it keeps getting bigger and bigger, as you can see. And then the text itself is resetting to be whatever the counter is holding on to, which is why it's going through that so quickly. Yeah, so that's what this program does. Let's try and do 1 or 2 ourselves using this counter pattern. All right, so bubble number 5 is, let's zoom in. Using the counter pattern, you can write programs that animate sprites smoothly, adding or removing from a sprite's X or Y property. In the draw loop, makes your sprite move just a bit each time it is redrawn, right? This is what I was talking about in the beginning one. So we're going to make your program to animate like the image to the right. They've already added the line to update plane.x in the draw loop, but it needs to be finished. So here, they started by drawing the plane, And then in our draw loop, we made the background sky blue, so it'll be resetting instead of a white background to be like a blue sky background. And then over here, they want to say, all right, the plane.x should be equal to, and this is where we actually have to change it, and then it just draws the sprites every time. So the counter pattern is always just whatever you have on the left side of your equal sign, you have to put in one of these two slots. I'm going to put it first. So the plane x is going to be equal to itself, and then we're going to change how much we want to change it by every time. So we'll try +1 every time. And if we run this after doing that, or, let me undo this for a second. If we try running this right now, it's going to give an error, and it's going to say, well, wait a minute. What is this underscore thing you've talked about? I don't know what that means. And that's just because we need to, fill those blanks in with this over here. So I try running this now. The plane is moving exactly how I wanted it, right? It's going from the left to the right. Every single time I move through this loop, I'm increasing the x coordinate of the plane by 1 using the counter pattern. And then I'm drawing the sprite, and then I reset the sky blue so that it looks like I'm, covering it. If you want to make it change in its y also, we can do that too, right? I can say plane.y is equal to plane.y, and maybe I'll do minus 0.5 to make it kind of go up a little bit every frame. So let's try that. And so now it's slowly moving up as it moves to the right, yeah? We can do all sorts of crazy stuff, right? I could do like +5 if I wanted to, and now it's going to move pretty fast to the right and very slowly up. I could also do a I always find this to be cool. Exponential is like super, super cool. If I do times 1.1, what'll end up happening is it's going to start really slow and then it speeds up. Maybe if I do even 1.01, you'll see it starts off really, really slow, and then eventually it's going to start speeding up faster and faster and faster. And that's not really that exciting. Maybe try 0.05, you can see it. Yeah, you can see it start like zipping off the screen, right? So when you're multiplying, it becomes an exponential function that you're doing instead of a linear function because you're multiplying the x every time, and it becomes, that curve, which is like super cool. Let's do, I think I'm actually going to end the video here. Hopefully that's helpful in understanding and seeing some concrete examples of how the counter pattern works. I might post another video later this week because there's a lot of bubbles here, and it gets like kind of crazy. But the counter pattern is like super, super cool. You can do a lot with it, changing more than just the x or y, but the rotation, the scale, anything, any variable that's being held onto, or rather that is holding onto a number, can use the counter pattern within a draw loop to do all sorts of crazy stuff. And if you don't just limit yourself to adding or subtracting, but you try multiplying or dividing too, things can get really wacky. So yeah, there's the video.